Hello, statistics students. Mr. Bolt coming to you from his office. Today, we are going to continue transforming our random variables. All right, we're going to be adding and subtracting, multiplying and dividing them. The difference is today, we're going to be doing both of those at the same time. So the examples yesterday were only addition and subtraction, or only multiplication or division. Today, we're going to be doing both at once, and we call that a linear transformation, because if you multiply and add, that becomes a linear equation. So you'll see that pop up a little bit here and there, but it is basically the same idea as yesterday. All right, now, quick reminder to you. The homework is due tomorrow, so that's what, semester 2, homework number 3 is due tomorrow. And we've got a quiz tomorrow as well. So quiz 3 tomorrow also. So don't forget that. All right, first though, if you haven't finished the Desmos from yesterday, could you pause the video and go check that out? All right, I want you to take maybe 15, 20 minutes. Don't take the whole class. You got to watch the rest of this video. But first, if you haven't finished yesterday's Desmos, that can be number 1 on your list. So take 15, 20 minutes there to try that out. But then make sure you do come back to watch the rest of this video. All right, welcome back. All right, hopefully you got that Desmos done. Let's take a look at a linear transformation here. All right, so we are going to be doing both addition and multiplication at the same time. Look at that cute little baby. Look at that cute little baby. So here's our problem. One brand of baby bathtub comes with a dial to set the water temperature. When the baby safe setting is selected and the tub is filled, the temperature of the water in a randomly selected bath follows a normal distribution with an average of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. Let y be the water temperature. All right, so we got our variable y. Let y be the water temperature in degrees Fahrenheit for the randomly selected bath. All right, 34 degrees Celsius doesn't mean anything to us. This is Merca, everybody. We don't know Celsius. We need Fahrenheit. So we got to convert this variable x. So we start off with x. That's Celsius. We're going to convert it into y, which will be Fahrenheit, which will make a whole lot more sense to us, won't it? All right, so our linear transformation is the equation that converts Fahrenheit to Celsius and vice versa. All right, so here is our linear transformation. We're going to multiply by 9/5. So we're going to take c, which I get as x. So for us, this is going to be the x right here, because that's the Celsius. All right, and then we're going to multiply by 9/5. Add 32. So those are our two transformations, and that will give us the Fahrenheit, which they said to call y. So our equation, I'll just rewrite it, is going to be y is equal to 9/5 x plus 32. So this distribution is going to change a little bit. How is it going to change? Well, the shape is not going to change. They said it was normal before. It's going to be normal afterwards. All right, so our shape is still going to be normal. All right, what about our center? What's the center going to be? Well, the mean they had, the mean of the variable x, which was Celsius, right? That was 34 degrees. All right, right here. We are going to convert that into the y's. What is the mean of this new variable y, which is going to be our Fahrenheit? What is that mean going to be? So we got to remember, all right, what happens when I multiply? Does the mean change? Yeah, yes it does. So we're going to take our old mean and multiply by 9/5. What about addition? If I add 32, does that change the mean? Yes, yes it does. That also changes the mean. So I have to do both of these transformations to the mean. And yes, all that means is you are plugging in 34. So we'll have 9/5 times 34 plus 32. Yes, we are just converting the 34 degrees Celsius into Fahrenheit. All right, nothing crazy there. So 9/5 times 34 plus 32 gives us 93.2 degrees Fahrenheit. So there is our new average. There's our new center. All right, what about the spread? All right, so the old standard deviation of the variable x was equal to 2 degrees. We're going to convert that into Fahrenheit and find the standard deviation of our variable y, which is going to be in Fahrenheit. Now, here's the thing, okay? This is a little bit different. Let's go back and do the same procedure last time. If I multiply by 9/5, does multiplying change the standard deviation? Yes, yes it does. All right, so we are going to multiply the standard deviation by 9/5. Same question. Does adding change the standard deviation? No. The plus 32 does not affect the standard deviation. The plus 32 simply slides it over. If you just slide it over 32, that doesn't change the spread. So the weird part here is for the standard deviation, we don't just plug it into the formula. We only multiply by 9/5 because the plus 32 does not affect the spread. It doesn't affect the standard deviation. So when I do this, I only multiply by 9/5 and I get 3.6. So the standard deviation is 3.6 degrees Fahrenheit. There we have it. So now we have the mean, the standard deviation, we know the shape. I can ask you a probability question using normal CDF. It's a wonderful thing. So what is the probability the bath water is more than 3 degrees Fahrenheit hotter than what it is supposed to be? All right, what is the chance that it's more than 3 degrees hotter than it's supposed to be? So I'm assuming that it's supposed to be 93.2, right? That's where we set it. That's where it's supposed to be. What are the chances it's more than 3 degrees hotter than that? So that's going to be the probability that the variable y is greater than plus 3 makes us 96.2 is 3 degrees hotter. So what are the chances that the y value is more than 96.2 degrees? All right, so that's going to be a normal CDF question. I'm going to draw the picture here. It's a great way to show your work. But we've got a normal curve here where the center is 93.2. The standard deviation is plus 3.6 minus 3.6 over and over again, right? And I want to know the chances that it is above 96. So somewhere over here is 96.2, and I want to find the area to the right. That's my normal CDF here. So I'm going to come over to my calculator. Mine on my computer is a little bit different than yours, but I'm still finding normal CDF. The lower is 96.2. It asks for all the same things. The upper is infinity, so 9999999. The mean is 93.2, and the standard deviation is 3.6. And so we get a 20% chance, 0.202. So roughly a 20.2% chance that the bath water is more than 3 degrees hotter than what it's supposed to be. It's kind of a big chance, isn't it? I'm not sure if 3 degrees would be enough to make a baby cry or not. All right, let's do one more together, and then I've got one for you to try as well. All right, Mr. Bolt's party bus business is getting slammed these days. Oh, man. He just heard about a new 10% tax on his party buses. Now, not only will he have to pay this 10% city tax, I will also have to pay the $150 for the bus to be cleaned every week. Oh, man. We're going to define the variable t to be my total profits after this new tax and the cleaning fee. All right, so I've got the old distribution that we have used so many times, right? It's this discrete random variable. Here are the mean and standard deviation that we've been using over and over and over again. All right, but we're going to convert those now. My new variable t, all right, I'm going to get taxed, and I got to pay the cleaning service. So what does this look like? All right, so first I'm going to take the variable c. That's my the cost that I get, not really cost, but the amount I get from driving the party bus. That's sort of my income. There's C. But now I get a 10% tax on that. Now here's how you do a 10% tax. If they take away 10%, I'm actually only left with 90% of my money. Okay, 90% of means multiply my money. So that takes multiplying by 0.90 takes away 10%. Okay, I'm only left with 90% of my money after that tax. All right, so there I've got my 90% still. I'm still holding my 90%. All right, the government took 10%. I still have the 90. But now I have to pay the cleaners. All right, they made a mess of my party bus. Shocker. Now I have to pay the cleaners $150. So here's my linear transformation. This is what my new variable t for the total profit I will have after the taxes and the cleaning fee. All right, so let's do the mean and standard deviation. What is my new mean? So I know the mean of C, the average of C is $562.50. What is the mean of T going to be? Well, just like the temperature problem before, you just plug this in because both the multiplication and the subtraction affect the mean. They both affect the mean, so yes, you just plug it in. So 0.90 times 562.50 minus 150. All right, so we just plug in the 562, the average, into our equation. All right, so once we do that, we will get, let me pull up the old calculator here, 0.90 times 562.50 minus 150. My new average is $356.26. So the mean of T, I just forgot that number, 356.25. All right, now the standard deviation. So my old standard deviation was 163, but I'm transforming the variable, so that's going to be different now. But we don't just plug this one in, right? The standard deviation of t is equal to, all right, again, multiplying by 90.90, that does change the standard deviation. So we plug it in right there, 0.90 times 163.46. But subtracting 150 does not change the standard deviation. Remember, that's just sliding it over. And sliding it over does not change the spread. So I don't subtract 150 here. I just do the multiplication. That's the only part that affects the spread. All right, so 0.90 times 163.46. 147 and 11 cents. 147 and 11. So the standard deviation of t is equal to 147.11. So we've described the mean and the standard deviation. This one would be a lot harder to ask a probability question on, so I'm not gonna. We would have to redo the table if we were going to ask a probability question. So I'm not gonna do that to you. I'll only do that to you if it ends up being normal, so you can plug it into the calculator. All right, I've got one more for you to try here. All right, look at that. Would you eat that cereal? Would you? Huh? I don't know. That cereal looks terrible. Just Oreo cookies in milk. I feel like it sounds good for the first bite, and then you would just get a headache after that. All right, so pause the video here. Work on this together. See if you're getting this and if it's making some sense. Talk to everybody tomorrow.